So, we all see what AI is doing, right? It's changing everything. But behind all that incredible software magic, there's a huge physical challenge. How do you actually build the infrastructure to power it all? We're talking data centers on a scale we've literally never seen before. But what if the solution wasn't some crazy new invention, but something a lot simpler, something based on, well, building blocks?
I know, it sounds a little weird, right? But stick with me because the answer to this question is really the key to understanding the future of computing. It's all about the power of standardized, repeatable blocks that you can just snap together to build something absolutely massive, complex, and incredibly powerful. Okay, let's get into it.
Now, the concept we're going to break down today isn't some flash-in-the-pan idea. This architecture has been battle-tested and refined for almost a decade. It started way back in 2010 with a first-gen design. The goal, even back then, was always the same: create a solid, standardized framework. And by 2019, it had evolved into this really slick fourth-generation solution. So this idea has been in the works for a while.
So, let's get to the fun part. If we're going to build with these digital bricks, we need to know what they're called. In this world, the single most fundamental building block has a name: the point of delivery, or as everyone calls it, a pod.
A pod is pretty much exactly what it sounds like. It's a complete, self-contained little data center unit. You can almost think of it as a data center in a box. It's got everything it needs to function all on its own, and it's specifically designed to be a blueprint that you can just copy and paste over and over again to scale up.
To really wrap our heads around what's inside a pod, we're going to use a pretty cool analogy. I want you to stop thinking of it as a machine and start thinking of it as a living organism. Seriously, it's got a skeleton, a nervous system, the whole shebang it needs to live and grow.
Okay, so every organism needs a skeleton, right? A structure. In a pod, that's the absolute foundational hardware. We're talking about the hosting racks that physically hold everything and the power infrastructure that brings it all to life. This is the basic frame that everything else gets built on.
Next up, you've got the neural functions, basically the pod's nervous system. The network switches and all the interconnects are like the nerve pathways that let information fly around. And right at the heart of it is the aggregation rack, which acts kind of like the brain, coordinating everything that happens inside that pod.
And finally, once you have the structure and the nervous system, you add the meat. This is the muscle. This is the stuff that does all the heavy lifting, the compute nodes that do the actual thinking, and all the different storage tiers that act as the memory. And this is the part you can really customize, adding more compute or more storage depending on what you need.
Now, this is what I think is so cool about each pod, just how self-sufficient it is. It operates all on its own. It's managed through code, which means you can deploy it super fast and know it's going to be the same every single time. It's got its own management tools, its own data protection, and it's so standardized that you don't need a team of IT experts on site to get it running. So we have our single cell or pod. But that's just the beginning. The real power, the mind-blowing scale, comes when you start combining them. Let's see how you go from just one of these units to a massive, complex system that can handle the biggest AI jobs out there.
The way this scales up is it's so beautifully logical. You start with your basic unit, the pod. Then you connect a bunch of pods together with a super fast network layer and you get what's called a bank. Okay, simple enough. Then you connect multiple banks with an even faster, ultra-high-speed network, and that gives you a farm. It's this clean, predictable pyramid, pod to bank to farm.
All right, so remember I mentioned this whole architecture was designed back in 2019? Well, this is where the story gets really wild. It turns out this design was, well, it was way ahead of its time. In fact, it's almost a perfect prediction of the industry standard design that is being pushed for AI clusters today. And here it is. This slide just lays it out perfectly. On the left, you've got the 2019 architecture we just walked through: pod, bank, and farm. On the right, you've got the modern standard from the Open Compute Project, or OCP. I mean, just look at the parallels. What they call the pod, the OCP now calls an XPU pod, where XPU just means any processor, like a CPU or GPU. The bank is basically their OpenPod group, and the farm is the XPU Open Cluster. The names are a little different, but that three-tiered structure, it's a near-perfect match. And this isn't just some happy accident. This quote here really nails it. These frameworks line up so well because they're both trying to solve the exact same problem. How in the world do you create a massively scalable, repeatable, and non-disruptive design for the insane demands of AI? The core ideas of modularity are just universal.
So, let's bring this all home. Why does this whole modular building block approach actually matter in the real world?
What are the actual benefits for any company out there trying to build this stuff, whether it's for AI or anything else?
The advantages are huge. You get insane scalability, right? You just add more blocks. You get speed and consistency because you're stamping out the same blueprint every time. Management gets way simpler. Support can be centralized, and that saves a ton of money. And maybe the most important part, you can expand without having to shut everything down. It's a model that just works, whether you're a small business or a giant cloud provider.
And that kind of leaves us with one last big thought to chew on. When the actual foundation of our digital world, the data centers themselves, can be built and scaled as easily as snapping together some Lego bricks, well, that frees us all up to focus on the next big question. So if the infrastructure is built from these simple, standard blocks, what incredible things are we going to build on top of it?